This is the Cockpit familiarization tutorial for the AGS37 Viggen. The number on the top left of your screen is going to indicate which number that part of the cockpit was given by the Special Pilot Instructions manuals. Left side dashboard. This is the AOA gauge. It's directly to the left of your HUD base and is a gauge starting from 0 and going to infinity, which displays the current AOA, or angle of attack, of your aircraft. The infinity sign is not reachable, but is meant to signify the AOA for a stall, as displayed by my friend who corrected me. Extensive and strong AOAs can cause a compressor stall. This is the master alarm reset button and 2 lights. If anything too critical works unexpectedly, for example the engine being on lower RPM than expected, the master alarm makes a beeping sound and flashes their 2 red lights. These 3 blue buttons let you switch between autopilot modes. Spock, translating to flight stick, is having autopilot off but having flight assistance. You can turn off any computer input by deselecting Spock. ATT means attitude and holds your current pitch while keeping your roll centered. Height means height and holds your altitude and centers your roll. The left light is an indicator telling you that the AFK lever is on, maintaining automatic throttle. The right indicator is a button that activates AFK mode 3, which should automatically maintain 15 degrees of AOA under certain conditions. This is the artificial horizon, displaying your attitude relative to the horizon, blue being sky, black being the ground in this visualization. The 2 yellow bars line up as a cross in the middle of the horizon when the navigation system is calibrating, and when it's done it moves to the bottom and to the right. The small knob to the bottom right is meant to manually adjust the artificial horizon vertically, but is not modeled in DCS. This knob to the right of the artificial horizon is your HUD brightness knob. Clockwise to make the HUD brighter, counterclockwise to make it darker. You're supposed to adjust it so that you see the HUD without any blurry outline while remaining as bright as possible. That brightness where it doesn't overexpose your eyes change at night. This is the speed gauge, measured in kilometers an hour and Mach. It tells you almost everything about your speed. The numbers are single digits to be easy to read, meaning you need to add 2 zeros at the end of every digit to make it the actual speed. The close together lines between 400 to 300 kilometers an hour indicate your landing speed, and the Mach number is displayed in the middle. The knob controls a small arrow that you can put wherever you want on the gauge as a reminder of what speed to keep. The thrust reverser closes a hatch in the exit of the engine, redirecting thrust through 3 holes on the upper left, upper right and bottom of the fuselage to push thrust backwards. It only activates on the ground, meaning that before landing, while lowering your landing gear, you pull the reverser handle as well, meaning the thrust reverser then automatically turns on when the landing gear touches the ground. This is the frequency selector for the radio. You can switch in between FM and AM with a switch. There are 2 knobs with inner and outer dials. The inner one, closest to the panel on the left, is to fine-tune the left digits. A few turns clockwise giving +1 input and vice versa. The outer left knob is +10 per turn clockwise and vice versa. The inner right and outer right knobs fulfill the same purpose, except they change the decimal numbers or last 3 numbers of the frequency. The altitude gauge was honestly hard for me to understand at first with the pointers, but it works like a clock. The thicker pointer is meters in thousands, the thinner pointer is meters in hundreds. Add 3 or 2 zeros according to each pointer to get rough and precise heights. The bottom left knob changes the QFE, which is an advanced math thingamajig that I do not have the brain or willpower to understand or explain, but it determines the height of the ground. Center dashboard. The central indicator is your navigation, RWR and radar screen. It seems advanced with how several things were compactly squeezed into this one gadget, but it's easy when you learn it. The compass is the most confusing part, opting for 2-digit numbers, making it take a second to comprehend which number is actually giving you. But every dash you see on the compass is 5 degrees, so go from a basic point, let's say 21.
It's pointed to 12 in the video.
Wait the fucking mouth! Let's say 21. Figure out that it means 210, and then if you want 220, it's just 2 more dashes clockwise. When you've entered in a waypoint, it gives you a yellow arrow that points directly at where the waypoint was set, meaning you don't need to count the compass digits and only need to turn until the yellow arrow has lined up with the white arrow at the top of the compass. The RWR is a relatively simple RWR system called the Apparat 27. abbreviated APP27 and means device 27. It has 6 listening antennas around the aircraft, giving you a 360-degree RWR listening area. It does not directly tell you what is locking onto you, but it gives you an audio signal at the same hertz rate as the radar, meaning you can technically identify what type of radar is locking onto you. This is not something I have achieved by myself, and it appears to be very difficult. Other than that, the RWR takes shape with audio beeping and 6 lights around your radar screen that tell you the general direction of where the threat is coming from, as well as blinking or lighting up along with the beep. Low beeping signifies a radar signature that something sees you, and a higher beep means it is locking onto you. It does not tell you if a missile is fired. There is a 7th light on the top left, which is a warning light for altitude. The parking brake is behind your flight stick and is pulled out when on. To turn it off, push the brakes or push in the lever. To turn it on, push the brakes in and pull the lever out. This lever is the pedal arrangement lever. It's used to account for height differences in pilots. Pull the stick and you can adjust how far away the rudder pedals are from the seat. These 7 buttons, if my research is correct, fine-tune the cabin lighting, possibly allowing you to turn off specific lights. It's not modeled in DCS, and I'm unsure if this is its true purpose. This button, labeled CI symbol, is a testing button. It is not modeled in DCS, but when pressed, I believe it would show important symbology on the radar to allow you to adjust brightness and contrast accordingly. This sight is a digital single-purpose sight for the RB75 Maverick AGMs. This is the HUD reflector. You can raise and lower the HUD in 2 locked positions with this lever. Right side dashboard. The clock is directly to the right of the HUD base and provides the actual mission time. You can change the clock time by turning the knob on the bottom left of the clock gauge. This light, labeled Feld Last, translates to dropped ordnance. It lights up when the last salvo of the selected ordnance is used up, telling you there's nothing left to shoot. On a planned mission where you have to turn around immediately, this is crucial information, as you want to turn around as soon as you can. That usually being when you dropped the last weapon. The switches underneath your clock gauge have 2 purposes. This switch, labeled Slav SI, has 2 modes, F and T, meaning från and till, or in English, off and on. When the switch is turned on, it takes away several unnecessary HUD elements to make it easier to fly in high-stress situations where you need to focus more on your surroundings, such as low flying. The other switch underneath your clock is labeled Höjd CI/SI, Höjd translating to height. That switch defines whether your altitude gauge is reading barometric altitude, or altitude relative to the set QFE ground level, or reading the radar altitude, which uses the air-to-ground radar to measure your actual height off the ground below you. RHM is radar altitude, LD is barometric altitude. Above 1000 meters altitude, you cannot select RHM. The G-force gauge measures the amount of G-forces in turns, relatively basic. It only reads up to 8 Gs, but your aircraft can survive up to 13 Gs. The transonic line activates between Mach 0.95 and 1.05 to alarm the pilot that the aircraft may behave differently while surpassing the speed of sound. This is a small display that tells you what waypoint you've selected. The backup artificial horizon is a smaller scale copy of the main artificial horizon, missing horizontal movement but still measuring roll. This is the backup speed gauge, being virtually the same as the main speed gauge, only missing a few details and the Mach counter. This gauge requires you to get used to Swedish measurements. It tells you the distance to the selected waypoint, up to 40 kilometers. Then it switches to a Swedish mile, or a mil. 1 Swedish mile is equals to 10 kilometers. The backup altitude gauge is virtually unchanged from the main altitude gauge, apart from the layout. It also features another QFE knob, which is only set in case of emergency, and does not need to be set if an emergency impossible or any possible emergency doesn't need a backup QFE. The RPM gauge measures the compressor's RPM in percent up to 110%, the main gauge being the N1 compressor and the small needle being the N2 compressor. Idle RPM is 60% on the N1 compressor and 0% on the N2 compressor. The N1 compressor is the main compressor used during flight, and the N2 compressor is the starter compressor. The EVK zone indicator, an acronym for Efterbrännkammare, translating to afterburner, is a set of lights below the RPM gauge with 3 letters, 1, 2, and 3. These lights indicate afterburner stages, which in real life aren't that important apart from takeoff, as you have to slam the throttle past the limit to go into afterburner, but in DCS with a HOTAS, it's crucial to know when you're in an afterburner. The backup compass is a copy of the compass around the radar screen, however missing the yellow waypoint indicator and RWR lights. The fuel flow gauge measures how much fuel is flowing into the engine in kilograms per hour. The fuel gauge is quite compactly informative while remaining simple to a trained eye. The thin white pointer shows you the actual fuel amount in percentage up to 135%. The black and white lined pointer is how much fuel you will have left when you've reached the selected waypoints. 100% fuel is a full internal tank. 120% is a full internal tank with a full external tank. 135% is for exceptions that aren't achievable in DCS. Hello, this is not nerding out me talking directly to you, whoever is watching this video. First of all, thank you very much for watching this. It takes a lot of time to perfect this video, and out of all videos I've made on YouTube, this will be the first time I'm asking someone this. Please comment anything. Say hi, tell me something I said wrong, tell me to fuck off, anything. It helps me to motivate me to make more videos by telling me someone is actually watching. I'm today on day 3 of making this tutorial, of which I know nobody but the real dedicated pilots are going to watch, because who would want to watch some Swedish guy yap about multiple instruments on a plane that you'll never use, even in DCS? Anyway, I hope you're enjoying my tutorial so far, and now for the left sections of the cockpit. Left front, the cabin pressure gauge. This gauge does not do exactly what you'd think it'd do. It measures the pressure difference from outside towards the inside of the cabin in kilopond per square centimeter, 1 kilopond per square centimeter being 0.98 bar. The brake pressure gauge shows the amount of pressure on the brakes using kilopond per square centimeter. The trim indicator shows the elevator trim. If the pointer is up, that means it's trimmed to point the nose down, as it says. If the pointer is down, that means it's trimmed to point the nose up. The center trim button resets roll trim to standard position. Above the 3 gauges I just showed you, there is a switch and a button. The switch here is an instrument light brightness switch set to either full or half. Set the switch to up for as bright as possible instrument lighting and down for half bright lighting. Turning it off is a knob that will be shown later. This switch is not modeled in DCS. The other button is the alarm test. You're supposed to test all alarms by holding this button after ground power is connected or the engine power generator is on. Verify all alarm lights and sounds are functioning. The emergency light switch activates emergency instrument lighting in case the gauges still work but lights don't work. The taxi and landing light switch has 3 modes. Off is middle, taxi is backwards, and landing is forwards. The KB switch is the flare release switch, allowing you to use 2 programs, cont and int, to release countermeasures. The only way you can drop your flares and countermeasures from what I've seen is the fast release keybind. This switch turns on the light for the left emergency instruction board. This is the canopy handle. Push it forwards to close it, and when it's closed, push it further forward to lock the canopy. It locks automatically. To open it, pull it backwards, and when it's fully open, return it to the middle. This is the left alert table. In a different tutorial, I will go through every single warning on the 2 warning tables, but for this tutorial, I'll tell you the 7 most critical ones. These 3 lights indicate that your 3 landing gears are properly extended, locked, and usable. The orange light above indicates something is wrong with the landing gear. These 2 red lights indicate you have a fire on board, and this orange light indicates you have an electrical failure. This is the FR22 radio. It's the main radio, and this panel controls radio channels. There will be a radio tutorial, but for now I'll explain the fact there's a hierarchic channel selector. These channels up here are your main channels. These 2 knobs, group and base selector knobs, choose which group or base you're part of. These 9 buttons are flight buttons, letting you select specific flights in the group or base. Thank you for watching part 1 of this tutorial. We've covered 4 sections: right dashboard, central dashboard, left dashboard, and the left front panels. I've decided to end the first part here because I need to make the rest of the tutorials for the vegan, and I've lost the initial push for this part. As you can see, the reason why I've decided to segregate these videos into parts is because we've only talked about the green circled areas of the cockpit, and it's a 14-minute long tutorial already. Either way, I hope you found this useful.